Welcome back everyone. Let's start our first practice lecture about our course Python Programming, a hands-on course for beginners. So what we're gonna do, as we've already commented a lot in the last video, we're gonna create now our first and actually only GitHub repository at GitHub. Then we'll clone that remote repository to our local machine so that we can work on it locally. We'll create an anaconda environment inside that Git repository, and then we'll show you how to create a jupyterlab or jupyternotebook file with some simple Python code just for testing if our environment is actually running. But we'll not enter in any details or in any specific topic of Python yet. This class is basically to implement and show you in practice how we can create a whole environment including the GitHub remote project, the Git local project, the Anaconda virtual environment, and our first sample Jupyter notebook file. And inside that Jupyter notebook file, we'll start including our Python code as well as some markup code that we can use to specify or to get a better presentation of our Python script. So if you haven't watched the last lectures, I invite you to do it before continue this lecture, because I'll not repeat everything we've already said before. And another thing is that you gotta already have a GitHub account created. You gotta have Anaconda already installed at your operating system, at your machine. And you also must already have installed Git. If you haven't done that yet, also get back to our extra videos where I show you in details how to use Anaconda, Conda, and how to do all the configuration regarding Git and GitHub. So starting from now, I'll assume you have already watched all the extra videos that we have available at the end of this course, and you have already watched the previous videos on which we've discussed in details all of this. So all practice now. Let's start our development workflow by creating a remote GitHub repository that we're gonna use for the whole course. Generally, when we create an application or when we want to create a repository for implementing that application, we basically create a single new remote repository and a local corresponding repository for each project we create. But exceptionally in our case, as we're gonna reuse the same environments for all of the notebooks we're gonna create, one notebook per topic, we'll simply create a single Git repository and put all those files inside. So we will not create one single repository for each of those notebooks or repeat the same environment creation for each of those projects because it would be redundant in our case. So the GitHub and Git repository we're gonna create now is the same one we're gonna reuse for the whole course. So how to create a GitHub repository? Let me show you now. So before we create our local Git repository or have it cloned from a remote repository, first we gotta create our remote GitHub repository, and for that you can open your browser and go to GitHub site, which is github.com. Let me increase here the font size. So this is the GitHub site. You can check it out later as you want. Here what we're gonna do is first sign in. You only can create a GitHub repository if you're signing in. So the first thing is to sign up if you haven't a GitHub account yet. But if you've already created your account, just sign in here, put in your username and your password. Okay, now I'm signing in. And now for creating a repository, you can go here to all repositories. Here are all the repositories I have. But what we want to do is to create a new one. So click here at this top right side button, new repository. And let's see what we got input at the repository creation form. So the first thing is the name of the repository we're going to create. And have in mind that the repository you're creating now is the repository of our course. So let's choose a semantic name that refers to our course. So let's use Python programming. As we're gonna see in Python, the variables that we're gonna create, they will not use the hyphen, because the pattern in Python is to use the underline to separate different words. But in this case, it's the name of the remote repository will be an URL, and by default the URLs on the web have the words separated by an hyphen. Here, even if we are creating a Python product, we should not separate the words by an underline, but by an hyphen, because it's not any variable at our code. It's basically an URL that will locate that repository or that resource on the web. So Python hyphen programming. This is the remote GitHub repository name, and it will be accessed, as we're gonna see, as an URL from GitHub site slash our account name slash Python dash programming. I'll just show you in a moment how to access the repository as a web resource. Down here, after you set the name of the repository, you can describe it, some description about what that repository means among all your other repositories. So this is the official repository for the course Python programming, a hands-on course for beginners. So the description can be basically that. Now, at the configuration of the repository creation form, you gotta choose if this GitHub repository will be public or private. And as the name implies, a public repository is one that by having its URL, anyone on the web can access it, including all the content inside, while a private one is available only to those, to yourself who creates the repository, and to those you give access to. So in our case, I'll create it as a public repository so that anyone can access it. You can also add a README file. I'll just show you what a README file is. It's basically a markup file that opens up every time you access the repository as the first file or the first description of that repository for anyone who access the repository. So it's a good practice to have a welcome file or a README file where you can put any links or any markup text describing better what that repository has in terms of contents, copyright notices, and so on. Here, a .gitignore file is basically a configuration file that tells Git, when we use it locally, what files not to commit to this remote repository. I'll show you in practice in a moment, but have in mind that we have different gitignore files. In our case, we'll just use the default Python gitignore file, this one, and I'll show you later that basically it contains some standard Python files or environment folders, folder names that should be excluded from any commit and push we're gonna do to this remote product. So it basically tells Git locally what files not to send to this remote repository we're creating at GitHub. So it's an exclusion configuration file that tells Git what files not to send to the remote GitHub repository. The add license option is basically for you in case you want to add an open source license, for example, MIT license or any standard license that you can reuse. But you also can add your own custom license at the README file. So it's basically what I generally do at my own repositories. I do not add a standard license, but I'll add my own license at the README file directly. So we can use it or not. I generally do not use it, but it's up to you. So, and finally, we click here the create repository button. So let's just review what we've already set. So the name of the remote repository at GitHub that will be part of the URL to access that web resource, which is the repository itself and all the content inside. The description, a short text as a description for that repository. The visibility, either public or private. The README file, which is a markup, a presentation welcome file that tells any visitor all the basics about the content of that project with an extended description and links and whatever. The gitignore file, which is a configuration file to tell Git locally what files to exclude when committing and pushing content to this remote repository at GitHub, and optionally the head license if you wish. So finally create repository, and that's it. So our GitHub remote repository for our course is already created. As you can see here at the URL field at your browser, you have already the complete path to this GitHub remote repository. https://github.com, which is the GitHub site, slash the user account, in my case DanielPM1982, and slash the name of the repository that we have set at the form, which is Python programming. So all that will be the URL for our remote repository when we access it, either at GitHub interface or from our Git, so that we can send or update or clone or fetch any content between our local repository and the corresponding remote repository. For now, the only content we have are these two files, the readme mg file, which doesn't have much content yet, basically the name of the remote repository, and that short text content that we have written at the form. But we can click here, edit file, and we edit that readme markup file to include any other markup content we wish. For example, a more complete description of the repository, some links for specific files inside that repository. So it's basically a welcome file for the whole project that turns available to the new coming person or visitor the most important aspects and contents of our repository. Here are the files of our repository, including any folders we might have. We do not have anyone yet, but we're gonna create some folders. Actually, we create one folder for each of our lectures, and inside each one of those folders we'll create our respective Jupyter Notebook files. So it's basically a root folder as we have locally at our operating system. So have in mind that this is all in the cloud. It's all in GitHub servers. It's not locally yet. And what you gotta do now that we have already created our remote repository is to copy that remote repository to our local machine, to our file system, so that we can work inside that file system environment and create all our products and then synchronize the local files created with this remote repository. So how do we clone a remote repository? As soon as we have already created that remote repository at GitHub, you just click here at the code button and copy the link of the repository here, copy URL to clipboard, and now we can open our prompt application. Actually, let me show you here something. Before you clone your remote repository, you should first go to your document section. In my case, as I'm using Linux, it's the home folder, and you should create a workspace folder, for example, Python workspace, just as a matter of organizing everything right in your local machine. So everything you gotta clone, we're gonna put here inside this Python dash workspace. So we'll open our terminal inside that folder. So here we are at our home directory, and inside the home we are now inside the Python workspace folder. So as soon as we clone any remote repository, that remote repository will be copied locally to a corresponding folder. So how do we clone it? Git clone, and the URL that we have copied from GitHub, which is this one, git clone, and the URL of the remote repository. So it will download the remote repository from GitHub to our local machine, and specifically inside this path where we are calling the git command from. In my case, inside home/Python workspace. So it will create the corresponding folder inside this other folder here that I have created for all Python projects that I clone. So press enter. Now it's cloned. If you look here, if you list all the files and folders inside this workspace folder, you can see the corresponding folder of the remote project we've created at GitHub, and now that we have cloned locally to our machine. So you can go inside it and see the files it has, which is basically the two files we've already seen at the remote repository, added with this .git folder, which contains all the configuration for the Git local repository. So remotely we do not have this .git folder, because it's basically for the local configuration of Git when managing this local repository cloned from the remote repository at GitHub. So this is our local repository for our project and for our whole course, Python programming. So now that we have created all our Git repository, both the remote repository as the local repository, what we gotta do now? Let's check it out here at our development workflow. We've created the remote GitHub repository. We've cloned it locally. We'll in a moment create a folder for this lecture example. And inside that folder we create the first Jupyter Notebook file for this lecture. But first, before we create any folder or any additional file, let's create the anaconda environment. And if you have already watched the extra lectures about conda and anaconda, you already know how to do it. So if you haven't, go back to those videos and watch them all, and then you come back here, because we will not be repeating everything again. We will simply use conda now to create the one and only anaconda environment at the Git repository we've just created. So let's create the anaconda virtual environment. If you have already installed Anaconda and Conda at your operating system and at your machine, how do you create a new Anaconda virtual environment? Basically by calling conda create and passing a prefix argument, which is the path where you want to create that virtual environment, and we can use simply /env so that it will reuse the current path, which is home/python workspace/python programming, and inside it will create another folder called env for all the configuration of the environment. So /env, and here finally at the end of the command line we pass all the labs that we're gonna add to that environment. Basically a virtual environment, it's a set of configurations for running common labs that we want our IDE, in our case jupyterlab or jupyternotebook, to be able to use. So conda will create this environment and add all the labs that we set here, or even later, even after having already created the environment. So, but for now, the only lab that we wanna add, actually the two ones, are the Python lab. Of course, we're gonna need the Python core lab to use Python at our notebook file. So you gotta add that core lib of Python as a dependency here, Python, and the other one you gotta use now is the IDE lib, which is jupyterlab. How do you know the names of those labs? You can search for them at any search engine, at the web, at your browser, or you can ask to ChatGPT or any generative AI. If you ask at the search input lab, conda, jupyterlab, then it will return the correct name and actually the site for that lab. We'll see every single lab in Python has its own site at the web, so it's very easily to find them. And also at the site of each respective lab, you also have the name of that lab and having it installed by conda. So we'll see later that we have basically two ways of installing labs for Python. The one we are going to use throughout the course is the most advanced and professional one, which is conda and anaconda, virtual environments, and so on. But you can also add using pip, which is another dependency manager, and is actually the native dependency management at Python. So if you use pip or pip and the name of the lab, you can also install it. And why am I saying this? Because the name of the dependencies will vary. For example, you might have some specific lab for installing from pip servers, which is different from the name of the same lab when having that installed from conda. So you just gotta be careful to use the right dependency name, but that's pretty easy to check out at the lab site. And if you commit any mistake regarding the name of the dependency, conda will tell you that that name you have used for that specific dependency actually does not exist. So you simply go to the site and look for the right name and then come back and try creating your environment again. Enough talking, let's create our conda environment here inside the Python programming folder, as we are passing here at the prefix argument. So dot, which is the current folder, /env, and then two dependencies. One is Python and the other is jupyterlab. So just press enter. In my case, I have already configured two channels for my conda dependency manager. One is the default, which is the default channel that basically exists at any conda installation, but I have already added the conda forge, which is another one that you can add. I show you how to do that at the videos about anaconda and conda. So if you do not know how to add new channels to your conda installation, just search for that at the anaconda and conda videos that are available at the end of this, which are available at the end of this course content. Here's the platform, collecting metadata done, solving environment. Here it confirms you where that environment will be created at. So here it's important for you to check this right. Why? Because if you, for example, forget to pass the prefix or pass any invalid prefix here, maybe it will create the environment at the standard anaconda installation folder, which is not what we want. We want our environments to be created inside each respective project folder, in our case Python programming. So that's why we passed here the prefix to be the current folder /env. So you just confirm it here. So /home /Daniel /Python workspace /Python programming /env. This is where all the environment files will be installed at our machine. And here the two only dependencies that we're installing right now. We can add later other dependencies, but the basic dependencies that we're gonna use throughout the course is the jupyterlab dependency, which is our IDE, Integrated Development Environment, and the Python core lib that we're gonna need for any of the projects we're creating. And here, for these two dependencies, jupyterlab and Python, it indirectly installs also all these other dependencies. So you not only install two, but for those two dependencies to be installed, you'll also have installed these other packages, and for each package you have the respective build, and here the channel where that package has been downloaded from. So I'm installing everything from conda forge channel, but you could also install from the default channel as well. Some specific dependencies, they do not exist at the default channel. So for example, some machine learning dependencies do not exist at the default channel. That's why it's a best practice to also add another well-known channel, and the one after the defaults, the one most known. In the case of Python, especially for data science and machine learning, is the conda forge. So if you have these two channels added at your conda installation, you basically find all the packages you want by just finding out the correct name for those packages or dependencies. So the following new packages will be installed. Okay. And then you confirm here. Yes. And it will install. Okay, so how you can know if Conda has installed all the dependencies successfully and created the environment? Basically, if you have shown at the end of your installation this information here about how to activate the just created environment. So this is the environment that Conda has installed with these two dependencies, the Python core labs and the jupyterlab dependency, with all the included packages for those two dependencies to work, and how we can activate. As you already should know, we just use conda activate and the prefix to the environment, which we can use simply /env. Okay, now we can see that we are inside the environment, or we are using the environment we've just created as the activated environment, and everything that we do here inside will take effect for that environment. So we can now open jupyterlab by simply using jupyterlab and it will open the browser automatically with the jupyterlab interface for that environment and for all those files and eventual folders that we have at that repository directory. So at the repository you have only the readme file. You can open here. It's a simple readme file that we can extend it. As we saw, we also have the .git folder that it does not show here because it's a hidden folder. So, but as you can see, we have the environment folder, which is the folder with all the installation configuration files for our environment, including any dependencies that we might already have installed. So now we can create here any folders for each one of our lectures. For example, for this presentation lecture, in which we are not starting seeing any content yet about Python, but only as an example here, we can create here a new folder. I'll call it lecture 00. I'll actually use a dash here, lecture 00. So it's just for this presentation practice lecture. I'll create this folder, and inside, if you open here, you can create a new notebook file, which will gonna have the .ipynb extension. So now I'll create our first Jupyter Notebook file inside the jupyterlab IDE, inside our local repository, of our course, and inside the lecture -00 folder of this local repository. So new notebook. Here you set the kernel, which will make Python work for this project. You can simply set the default here. Always start with the preferred kernel, select, and it creates a notebook with the extension I, Py, and B. And B is from notebook, Py is from Python. And you can rename this file with any other name you want. For example, I'll just repeat the name of the folder, lecture -00. You can use any name for this notebook file that you wish. The name won't matter in our case. And this is the first notebook we're creating at our course. You can hide this part of the IDE here at this icon here. If you want to open again the file part here of the IDE, you just click again. And now let's write some code in Python finally. And basically I'll show you how to alternate to write at your notebooks either markup code or Python script code as you wish. So the big difference in notebook files is that you can use markup code for describing or for writing in HTML code inside your project script, or you can use, of course, the Python code for defining your algorithms and later run those algorithms as your Python program. So have in mind that your notebook is basically a web app, so that's why it's running inside a browser, because Notebook Lab or Notebook is basically a web app. So if you want to increase or decrease the size of the font or the size of the cells of that app, it's like any web page. You can increase or decrease the size of the web page. I generally use it at 160%. You can set whatever zoom you want. Another important thing is how to create new cells. Observe that any notebook is composed by any number of code cells or script cells. The script is not continuous, although when you set it to be run, it will run as a normal script, but at the notebook it's organized into cells, and it also turns available that you can run only a single cell or some specific cells and not the whole script at once. So we see all that throughout the course, so don't worry with that yet. What I wanted to show you here is some basic interface aspects of the notebooks that we're going to create for each of the lecture topics. So this is just the first notebook we are creating for this presentation lecture. If you click here inside a cell and press Ask, you can add new cells below by pressing B at your keyboard. So here I'm creating new cells. Now we have 3 cells, and we may add now different snippets of code inside each one, having them organized at the respective cells. If you're here, for example, at the third cell and you want to add another cell here between the second and the third cell, you also can create a cell above the current cell by pressing A from above. So you can create cells below with B or above with A. So now it has created this new cell here above where we were before. So how do you create new cells? With the letters A or B at your keyboard. How do you delete those cells? You click at the cell, press ESC, always press ESC. If you do not press ESC, it will be at the edited mode, and the keyboards for managing the cells won't work because we'll be editing the text and not working with the cells at that edition mode. So you gotta press ESC to go to the unselected mode. The cell will be selected but not the text inside. So for example, how to delete this cell? You click at the cell, press ESC, and then you double press the D letter at your keyboard, D from delete, so you press it twice. And that's how you can delete by default any cell at your Jupyter Notebook file. Now, some very crucial selection commands that you can also do with your keyboard is how to set any of these cells to work with markup language or how to work with Python language. And basically that's also very easy. So click at the cell, ESC, and then you can press either M for markup. Observe here that the markup option has been selected, or if you wanna write in some Python code, instead of M for markup, you press Y. So now it has the code option here selected, which means you wanna write some Python code. Okay, so you can either use any of these cells as a markup language cell, or you can use it as a Python script code cell. So in our case here, I want to first create a title. So a title is not a Python code, it's a markup code, an HTML code that will be created from the markup language we set here. So we gotta change to markup or markdown code. And one of the special chars that we can use is the hash symbol or hash char. It's similar like the P element of the HTML. So if you want something similar to an H1 HTML element, you use one hash char, which is basically what we want here because we want a big title. So this is a simple title for this sample Jupyter lab file. So this whole content here is a markdown code, and we have selected this specific cell to interpret markdown code into HTML code. So we then press Ctrl or Command Enter, and here you have your equivalent HTML output for that markdown code you've just written. So now let's create another cell below. So press B. You can use, for example, multiple hash charts for creating smaller size text. So let's change again to markup code and use, instead of one hash symbol, we'll use, for example, 3 hash symbols for a subtitle. So this is a subtitle. whatever. Control Enter, and now you have a smaller size text. You can also add or set bold text or italic text or any font configuration similar to HTML effects for the text you write. I'll not enter into that. If you wanna learn more about markdown text or markup text, you can go at the web or at any generative AI application you like, and you see all the specific charts that you can use here when selecting the cells to work with markdown text. So now let's just try a Python code. So let's create another cell below, and instead of markdown we'll use the code option here by pressing Y, and by default it already appears as a code cell, so we can simply write some Python code. For example, print. You can use in Python both double quotes or single quotes. My name is Daniel from danielpm1982.com. Just be careful to end with the same quote pattern you use at the start of the sentence. So if you have initially used single quotes, end with single quotes as well. So do not worry with the Python syntax that I'll be showing you here at this specific notebook file, because we'll see all of this step by step in each topic that we'll tackle throughout the whole course. And for each topic we'll create another notebook file with all the details that you gotta learn about that specific topic or that specific syntax. Here I'm just showing you some random syntax with Python just to show you how to use notebooks and alternate from markdown cells and code cells or Python script cells. So I'm just using the core Python print function here with some text here inside. So Control Enter, and here you have the output for this specific code cell or Python script cell, and for this specific snippet Python code or script inside this specific cell. So if we create another Python cell here below, and for example if we print another thing, or even if we for example use another function, instead of using functions we can also use math operators at once directly. So here is the output for this specific cell or Python code cell we have here above. Observe that when you run a specific cell, the output that is shown is only for the content inside that single cell with that snippet code inside. So it will not run the whole script, it will run only the script inside that specific cell if you press Ctrl or Command Enter. Either here, at this one, or at this other one. If you wanna run the whole script at once, you can also do that by selecting here kernel, which is basically the server that is running this web application, which is the Jupyter application. So you can choose here kernel, restart kernel, and run ourselves. We'll see that in many situations we'll have to do this for running the whole script or the whole notebook at once. For example, if we wanna reload any initial declared variables from our notebook, we gotta rerun the whole script and not only specific snippets of that script or specific cells. We gotta rerun the whole script. So for that, you can only select here kernel, restart kernel and run ourselves, restart, and it will run each one of the cells in sequence. So first it ran this first cell here, this first code cell with this print, and here's the output. Then it ran this other cell in sequence with this other output here. So that's basically it for the basics of using Jupyter Notebook files and its interface, or Jupyter Notebook and jupyterlab IDEs inside your browser as a web application. And if you check here at the prompt, you can see that it still runs here outside the prompt itself. So until we finish or we close this prompt, this is the server that is making this web app run. So as soon as you close this server or this prompt or the anaconda environment that we are using, if we close it, then the web application here of the Jupyter Notebook won't be available anymore. So it doesn't erase the notebook file, but it stops the kernel, and if the kernel is stopped, you can't run any of the contents of the notebook or have an output or whatever. So for us to have the notebook running or have any output of what we write inside the cells, we gotta keep the Jupyter Lab or the Jupyter Notebook server running here at the prompt. As soon as we finish our notebook file, then we can close both the browser as the prompt where we started the JupyterLab application at. By doing so, we'll close the server and we'll close the web application, which is the JupyterLab or the Jupyter Notebook as well, but we do not erase the files. So the files are persisted here. For saving it, you can use here the save button or Ctrl S. Ctrl S, it's saved. So you can then close the browser as well as the prompt by closing here at the X and close a terminal, or by using Ctrl C. And as you see, it has shut down the kernel as well as the notebook execution. But as we can also see, the files are all persisted here. The env folder, it's persisted. The git local repository folder, it's also persisted. The git ignore file, the IPython checkpoints. This is basically some save points that Jupyter Notebook saves, but it's not importantly actually. It's also some of the exclusions that our git ignore file sets for when you commit and push this local repository content to the remote GitHub repository. It will not send this .ipy notebook checkpoints because it's not needed. It's basically for local management, but it's not important for the content itself. And here the lecture 0 folder with the Jupyter Notebook file we've just created and the readme.md presentation file. So if we go to the lecture 00, we have the lecture 00 dot ipython notebook file. If we try to see the content, for example with the cat command from Linux, of the lecture 00 ipython notebook file, you can see that it's not pretty much readable. Why? Because it's rendered from the notebook. It's similar to a JSON content that only the notebook IDE is able to interpret and show at the browser. So if you want to see that file again, if you have the environment activated already, as we still have here, you just open again the JupyterLab and you open the Jupyter file there at the JupyterLab IDE. So here it is. Just click twice and you'll be able to run the same Jupyter file again. Just by selecting here at the kernel, restart kernel and run on cells, and it will run the updated current version of that notebook content, the whole script at once. So that's basically it. So let me just close it again. And let me go here to our workspace, Python workspace, Python programming folder, which is the folder of our course. Now let me open the terminal again here. Inside, observe that we are not with the environment activated at this time. Why? Because what we want to do now is to have all this content we've created committed and pushed to our remote repository. This is the local repository. This whole folder is the local repository, but we gotta send or synchronize the same local content with the remote content we have at the GitHub remote repository. So, but first, another important thing that I was almost forgetting to tell you is how to create the environment.yml file. And why do we need that? Because if you check the environment.folder size, let me check here. Environment folder properties. You see how big it is, not in terms of local persistent memory, but in terms of if you would want to send it or update it in cloud, it would be very costly to keep sending the environment folder to GitHub or to any cloud you were using. So we do not actually send the Anaconda environment folder to any cloud. So what we do, we actually create a text file, and of course a very economic file in terms of size, called environment.yml, that will contain all the dependencies and prefix and all the blueprint for creating or recreating that environment. You will not have to have the env folder copied from the GitHub repository. The person will only have to download along with the clone of the GitHub repository, the environment.yml text file. So with that, he'll be able to use a specific conda command with the environment.yml text file to recreate the environment when he clones the GitHub repository locally. So how do we do that? How do we create the environment.yml from this current conda environment? So first we gotta activate the environment again. So conda activate dot slash env. So with the environment activated, we then use the conda command conda env export. We are exporting the current activated environment metadata to an environment.yml file, a text file, setting that we do not want to have any dependency regarding the operating system at the machine, so that anyone can clone the GitHub repository and recreate the anaconda environment, whatever operating system he has. So I explain all this in detail at the conda and anaconda lectures that you might already have watched. So let's just call this command and export everything you gotta need to recreate this current anaconda environment from this environment.yml text file. Okay, now we can deactivate the current environment, conda deactivate, and if you see now the files we now have the environment.yml file, and if you check the contents of that file, it basically has some text information regarding the prefix for this project environment, the prefix that I have used at my machine. Of course, when you create or recreate the environment, you may change, and it will override this prefix information, the name of the environment and the prefix path as well. But what's important here is the channels that we have used to import or install those dependencies from, and the name of the dependencies. Here we have only these two dependencies, but we could have, for example, 20 different dependencies at our environment. So basically this is the text content that we gotta need to recreate the same anaconda environment when we, for example, clone this GitHub repository again from GitHub. So as we will not commit or push the env folder to GitHub, when we clone the project again, we won't have this environment folder created. We will have to create it from the environment.yml text file. So we basically always do that. Locally we work with the environment folder, but when we commit and push the project to GitHub, we do not push or commit the env folder itself. We only commit and push the environment.yml, which is basically configuration file for recreating the same environment again after we clone again that GitHub remote project to any machine. So for example, here we can simulate having the same project cloned again to our machine from GitHub by just excluding, remove the env folder. So now observe that we have no environment folder anymore. We have deleted that, and by doing that we simulate having the same project downloaded again from GitHub to our local machine. So as soon as we clone that project to any other machine, we have only this content and not the environment folder. So we gotta recreate the Anaconda environment again so that we can activate it and use the dependencies inside. So how do you do that? We use this other command, conda env create. Do not forget the env, it's not conda create as we have used initially. We are now creating the environment directly from the file, so we gotta use the conda env create dash dash prefix or p, the path for the prefix, which is the dot slash env again. We use the same path for the environment. You could use a different environment path, but I'll keep the same. And here importantly the dash dash file with the name of the environment.yml file, which has the information needed for conda to recreate the environment with the exact same dependencies we had before. So dash dash file and the name of the file, which is environment.yml. So press enter, and then conda will recreate the same environment so that we are able to activate it again and access and run our Jupyter Notebook file. So it has recreated the environment. If we look at the folder contents, it's now with the environment folder again created. Then we can activate it by using conda activate dot slash env. So it has activated the environment, and we can open jupyterlab to access the Jupyter Notebook file and run it. So lecture 00, here is our notebook Jupyter file, and we can run the whole script here. Add kernel, restart kernel, and run ourselves. So it has run the whole script again, and here is the updated outputs for this run. So one last thing that I would like to show you is how you can commit and push the local content of our local repository to the remote contents of the remote repository at GitHub. So let me close the server here again, and we may deactivate the conda again. So here's what we gotta commit and push to GitHub from this local repository here. Let just me show you the .getignore file. So by default it's actually an exclusion file created by GitHub people, so they have already added here the most known file and folder names that we want to exclude, get from committing and pushing to GitHub because we do not need that. So for example, the build folder, the pyenv folder, the env environment folder, it's excluded. So as we have this env folder name as an exclusion for Git not to commit and not to push to GitHub, although we have it at our project, we have the env folder here, but it's excluded here at the .ignore file or configuration file. So when we set or ask Git to commit and push all these project content to GitHub, it will simply ignore the env folder because it's included here as an exclusion at the .ignore file configuration file. So that's basically what the .gitignore file does. It basically includes some file and folder names should not be committed or pushed to GitHub. So, and why is that important? Because for us to commit initially locally and later push that commit to GitHub, we first gotta use this command git add dot, so that Git will add all the content of this current folder and subfolders to the staging area, which is a temporary area that Git uses to add the content that it is about to commit somewhere. In this case, it commits locally here to the .git folder initially, and only then it pushes to GitHub. So, but before it adds the content to the staging area, so we always gotta use this git add dot command first before any commit. So git add dot, and then we can call the command git dash m from message. So we are asking Git to commit the contents at the staging area and set as a message for that commit and message we want. For example, add lecture dash 00 content. So git commit dash m and the message that we want that commit to have, which is add lecture dash 00. So enter. It has committed all the contents that was added to the staging area of the Git. Have in mind that the staging area as well as the commit area, they are included here at the .git folder. They are local areas of Git. And now we can finally push everything that we have already committed to GitHub. So first let me show you the working area here of the remote project at GitHub. Observe that we only have these two files, the .gitignore and the readme.mg. If you press F5, you still have only these two files at GitHub, at the remote project. What we're doing now is to not commit, we have already committed locally. What we are doing now is to push those committed contents to this remote working area at the remote GitHub project, synchronized to our local project. Let's now push all committed content from our local Git project to our remote GitHub project working area. So git push username and the password to your GitHub account, which is basically a hash code that you must already have configured at your GitHub account. If you haven't done that, look for it, how to configure your password as a hash key at your GitHub account, so that you can use here when you push any local Git content to your GitHub remote account. So you gotta use the username, in my case it's DanielPM1982, and the password, which must already have been set at your GitHub account. Okay, now it has pushed all the commits we had locally to our remote GitHub repository. So if we now go to the GitHub repository page and update the page, pressing F5, we'll see that we not only have the two initial files, but now we have the lecture-00 folder, as well as the environment.yml file we have just created. So if we open here the lecture-00, we'll have the lecture00.ipython notebook. If you open here remotely at GitHub, you'll be able to see the last state of outputs of that notebook file. So now, as we have an updated GitHub remote repository with our simple Python notebook project here, the notebook file here, we can use this same URL with GitHub, from GitHub, with, for example, Colab at Google, to create a new URL with Colab for automatically opening this GitHub remote repository Jupyter file inside the Google Colab platform. If we want to share that with others, for example, you can open it here directly at GitHub, but sometimes it's not the better place to open your notebook file, because for some labs it will not work. So the best way to open it, either theirs or any other notebook file you create, is at Google Colab. If you want to open it remotely in cloud, for example, when sharing that with others, for others not have to clone your repository locally, have an anaconda installed and create the environment locally and all that, you can simply share that Google Colab with that person, and that person will open it at Google in cloud directly at Colab. So let me show you now how to reuse this URL from GitHub, from your GitHub project with Google Colab. So if you open the Google Colab by opening your browser and searching for Colab, Google will ask you to sign up and sign in to Google Colab platform by using your Google account. That's why you gotta have a Google account to work with Colab. But you can easily synchronize the GitHub project with Google Colab link by simply using some standard URL pattern here that I'm gonna show you, which is this one: https://colab.research.google.com, which is basically the standard base URL of Colab, then /github, as we wanna import a remote repository from GitHub to synchronize that or to integrate that with Google Colab platform, and open that notebook at Google Colab instead of at GitHub, but we are importing it from GitHub. And then the URL of the project that we are importing from GitHub. If you go here at GitHub to the notebook direct link, which is this one, github.com /daniel1982 /python programming /blog/master/lecture00/lecture00.ipython-notebook. So if you copy this whole URL to this other standard URL, excluding of course the HTTPS and the github.com, you have this link that you can call from any browser anywhere in the world without having to even sign into Google. So it's much easier for others to access it. You just have to copy that or share that with anyone you like, and it will open the IPython notebook at Google Colab platform. So here it automatically integrates and synchronizes the GitHub remote product you have at GitHub with Google Colab platform through a simple URL. You do not have to sign up or sign into Google Colab, actually only if you want. But for example, if you want to edit this file, change it somehow, or run a current output from it, then you would have to sign in for running this online at cloud. But if you simply want to see the last output of the file shared from others with you, you simply have to call from a browser, any browser, the URL that combines the GitHub URL with the Google Colab URL into one single link. So in short, you just have to join these two pieces of a link, which is this basic one, https://colab.research.google.com/github/ and the URL of your notebook file, starting from your user profile name / the name of the remote repository /blob/master/ in this case the inner folder we have created, lecture 00 / lecture00.ipython-notebook. So you gotta pass the whole link, starting with the Colab base link until the notebook URL for accessing that notebook resource. So basically that's it. We'll see a lot more throughout our lectures, but this is what I wanted to show you at this presentation lecture, at this initial lecture, about the whole workflow we'll be using at our course. So we have executed this whole development workflow, and we'll only do this at this time. Why? Because in the next lectures we'll start seeing step by step each Python syntax subject, and we'll not keep recreating the GitHub project or cloning it locally or creating the anaconda environment again and again and again, because that will be too repetitive and redundant in our case. What we'll be simply doing is creating new notebook files inside new specific respective folders, but all inside the same repository we have already created, both remotely at GitHub as locally using Git and reusing the same anaconda environment that we have also already created. So thanks again, and I hope you liked this lecture, which was basically about figuring the whole environment we'll be using throughout this course. And starting from next lecture, we'll dive into all Python specifics step by step regarding each core lib subject of Python. So see you next lecture. Bye bye.